little bit differently. And we're going to spend 2 days on this because today we're going to spend mostly on just like converting and getting comfortable with this new form of exponent, and then tomorrow we'll throw in some that actually have our properties of exponents along with it, like our product rule, power rule, etc. So the warm-up just wants us to practice simplifying our exponential expressions. So this is actually like something we did already in section 7.a, our practice day. What would 2 to the negative 4th be? 2 to the negative 4th. Garrett? Close. Austin? 1 over 16. So remember, a negative exponent moves to the denominator, becomes a positive exponent, and then we would evaluate. So 1/16. Same thing with the next one. We have a lot of negative exponents. This one, this whole thing is being raised to the negative 2 power. So it has to move to the denominator and be raised to the positive 2 power. Then we would evaluate each of these squared. So 3 squared is 9, and x squared is x squared. So you guys, if you guys can complete the next few, and we'll go over the integer exponents, we're going to see rational exponents. So for example, x to the 1/2 power. We're going to learn what that means in terms of an exponent. And we will then tomorrow apply all of these rules of exponents, but with rational exponents as well. So a rational exponent, this is like our formal math definition, says that the nth root, which is any type of root, could be just cube root, fourth root, whatever, of a is a real number and m is an integer. Then a to the 1 over n power is equal to the nth root. And if you see a to the m over n power, that will be the nth root of a to the m. Or you can also write that as the nth root of a parentheses to the m power. So let me show you with some numbers. So if we have x to the 2/3 power, the numerator of the exponent will remain the actual exponent. The denominator will become the index of our root. So if you were to rewrite this in radical form, this would be the cube root of x squared, or you can also write it as the cube root of x quantity squared. It doesn't matter which way, they're equivalent. Now on the front we have all numerical examples. They just ask us to simplify. I want to do these without a calculator, but you technically can type this in your calculator with the caret symbol and just use fractions. So I'll show you that in a second, but I would like us to do these by hand just by converting them to radical form and then taking the root. So again, the denominator is the index of the root. So this would be the 4th root of 16, technically to the 1st power. What is the 4th root of 16? 2. 64 to the 1/3. It's the cube root of 64. And the cube root of 64 is 4. Again, we're just assuming that there's like an imaginary positive sign on here. That's why we're not putting our plus or minus. But technically, all of the even roots could get a plus or minus with them if we wanted to. But again, your answer keys on your homework aren't going to have that because our book doesn't. They just always take the principal root. Now we have two things being, the base is the same, so it's 2 to the same power. So would I add the 1/2 and the 1/2, or would I multiply the 1/2 and the 1/2? Add them, yes. So this would become 2 to the 1st power, which is then just 2. Now an alternate way you could solve this is you could actually take these and make them radicals first. So 2 to the 1/2 power would be the square root of 2 times the square root of 2, which would get you the square root of 4, which would get you 2. So 2 different ways you can do that same problem. See if you guys can try the next 3. And we'll go over those. And then I'm going to show you also how you could type this in your calculator, although we want to be practicing without, of course. But just so you're aware. Be careful with 5 and 6 because they do not have the same bases. So you cannot just say it's 5 to the 6th power because they don't have the same base of 5. In order to use the exponent rules, the base has to be the same, like x's, y's, 5's. They have to be like bases. What do we get for 4? Awesome. 7. 7 to the first, which is 7. Now again, these are not like bases, so you cannot add the exponents. You could change 25 to be 5 squared if you wanted to, and then you would get 5 to the 2/3, but most of you won't think of that. So I would just go to radical form. So this would be the cube root of 5 times the cube root of 25. And then we know we can multiply roots if they have the same index, which this does. So we can multiply our 25 by 5. And then what do we get? Garrett? Good. Cube root of 125, which is 5. Similarly with this one, this is not like bases. So I would just go straight to our square root of each, because that's the 1/2 power. Multiply those, and take our square root. There's a chance that it won't always come out to be a whole number. It could be a root. Now on the back, we're going to give you radical form with variables and ask us to rational form, write it in radical form. So they just want you to practice converting from this form to this form, and then we're going to go from this form back to this form, just to make sure that you understand again what goes where. So remember that the denominator is the index, and the numerator is the exponent that will stay. So this would be the 7th root of x squared. Or, this is how I like to write it, but you also can do the 7th root of x quantity squared. But I usually don't do that because it's more pen strokes, but that is the equivalent form. Now with our negative exponent, you still have to use your negative exponent rule. So this would be 1 over y to the 3/8 power. Then we would use 8 is the denominator, so that's going to be the root. So this will be 1 over the 8th root of y cubed. And you do not have to rationalize this, they just want us to write it in radical form. If it would say simplify, then we would have to multiply to rationalize, but we don't have to. Now what do we do if there's a decimal? Abby?
Would you make it into a fraction?
Yeah, make it into a fraction. So remember, decimals, we have the tenths place, the hundredths place. You just have to put that number over 10, 100, 1,000, depending on what it is. So this is the tenths place. So this is really z to the 4/10, which would be z to the 2/5 if we reduce it. And so that would be the 5th root of z squared. The last one is almost the same, but it does have a negative. So the negative comes first, so we'd have 1 over y to the positive 4th power, or 0.4 power. And then again, I would change the 0.4, just like the last one, would be 4/10, which is 2/5 again. So this would be 1 over the 5th root of y squared. 11 through 14, see if you can try these. This is working backwards. So going from radical form, go back to exponential. So the first one I'll get you started. Remember, this is going to be the denominator, so it'll be x to the 2/3 power. See if you can answer the next few, and then we'll look at a word problem. Rayleigh, what'd you get for 12? 3/4. Good. How about for 13? Sam? 3 over what? 1. What's the imaginary index of a root? Yep. So the index is, and normally if there's no exponent it's a 1, but an index is a square root, which is a 2. And then the last one we should have be to the, is it 3/5 or 5/3? Garrett? 5/3. Perfect. All right, now the word problem isn't as bad as it looks. It's like a whole paragraph. They give us a formula. So bone loss for astronauts on a lengthy space voyage may be prevented with a bed-like apparatus that rotates to simulate the effect of gravity. In this formula, which is the most important part of this, n is the rate of rotation per seconds, a is the simulated acceleration, r is the radius of the apparatus in meters. So it's important to know what the variables stand for to know when they give you numbers, where am I plugging those numbers in? How fast would an apparatus with a radius of 1.7 meters, so radius is obviously r, have to rotate to simulate a gravitational acceleration of 4.9. So a is the simulated acceleration. And then all we have to do is substitute into our formula and simplify. So we'll have 4.9. Now, you can change that 0.5 to be the 1/2 power, which would be a square root, right? But you actually could leave it 0.5 if you prefer. So we'll have 2 pi times 1.7 to the 0.5 power. And you're going to have to use your calculator regardless because we don't know what the square root of these numbers are off the top of our head. So in your calculator, if you want to put in an exponent that's a decimal, you just use your caret button and then you would type in the decimal, so 0.5, or you could actually even just put in 0.5. Now, we probably don't want to round this number because it has a bunch of decimals. So I'm going to leave it in my calculator and I'm going to divide by, and I would like to type this whole thing in. So I'm going to have to use parentheses because there's more than one item that is being divided in our denominator. So I'll use parentheses, 2. Our pi key is second caret. And then I'm going to have to put, well, I really don't need another set of parentheses because it's not a negative number. So I could just do times 1.7 caret 0.5. And then close my parentheses. And I got my answer, which is 0.27. They didn't tell us what to round to. We'll just do hundredths. And then we have to go back and figure out what the units would be based on the word problem. So n is the rate of rotation in revolutions per second. So this would be revolutions per second. Last one says the time t in hours needed to cook a pot roast that weighs p pounds can be approximated using this equation. So these aren't really hard word problems because they give you the equation. You don't have to come up with it. You just have to make sure you plug in the number in the right spot. To the nearest hundredth of an hour, how long would it take to cook a pot roast that weighs 13 pounds? So 13 pounds is p. There's a chance they could give you t and ask you to solve for it as well, but this one doesn't. So we just have to evaluate. And that can go straight into our calculator. If you wanted to, you could change this to be 6/10, which is then 3/5, and you could take your 5th root. But it's actually easier to put in your calculator if it's this instead of a 5th root of something to the 3rd power. And we should get 4.15 hours. Going back to the front really quickly, because I said I was going to show you and then I didn't. If you want to type in like 16 to the 1/4 power, which again I'd like you to do without a calculator, but you can type it in as a fraction, but you do need to put parentheses. So 16 caret, and then you'd have to do the 1/4 power in parentheses, and you would get your 2. Okay. All right, homework is on Google Classroom. We do have a test coming up on Tuesday the 6th, and then we are going to have our quarter 3 exam on Thursday the 8th. The end of the quarter isn't actually until the 22nd, but we just got to the point where we finish everything that's on the quarterly exam, so we'll take it that way. I'm not teaching you new stuff, and then that's not going to be on your quarterly, and also that way you won't have a million quarterlies in 1 week, so you'll have one less to worry about closer to the end of the 9 weeks. But those are your only two probably big. I don't think we won't get in the 7.5 to 7.8 test before the end of the 9 weeks. So those are your next really big grades, besides homework and partner challenges, of course.